In July 2022, NASA released an image from the James Webb Space Telescope that covered an area of sky equivalent to a grain of sand held at arm's length. Just that tiny speck. In that image were 45,000 galaxies, not stars, galaxies, each containing hundreds of billions of stars, each potentially hosting trillions of planets. But here's what made astronomers go silent. Using Webb's unprecedented resolution, they calculated that if we could see the entire sky with this level of detail, the observable universe contains approximately 2 trillion galaxies. That was the old estimate. The new calculation, based on Webb's deep field observations, over 20 trillion galaxies. We were off by a factor of 10. The universe isn't just bigger than we thought. It's incomprehensibly, terrifyingly, beautifully larger. And we're only beginning to understand the true scale of what we're living inside. The image that changed everything. Let's start with that image, Webb's first deep field. It looks like someone sprinkled thousands of glowing objects across black velvet. Beautiful, abstract, easy to look at without grasping what you're actually seeing. Every single point of light in that image is a galaxy, not a star. A galaxy containing 100 billion to 1 trillion stars. Think about that. Each fuzzy blob represents more stars than humans who have ever lived on Earth. And this image covers 0.01% of the sky, 1/1000th of 1%. If you held a grain of sand at arm's length against the night sky, you'd be blocking out more space than this image covers. NASA released this as a demonstration of Webb's capabilities, a before and after comparison with Hubble. Same region of space, same area. But Webb's infrared vision revealed thousands of galaxies Hubble couldn't detect. Faint, red, distant galaxies that formed when the universe was young. Galaxies whose light has been traveling toward us for over 13 billion years, stretched into infrared wavelengths by cosmic expansion. Hubble could see maybe 5,000 galaxies in its deepest fields. Webb sees 45,000 in the same area. And these aren't just background noise. Each one is a massive stellar system with its own structure, evolution, and potentially life. Dr. Jane Rigby, Webb's project scientist, said something during the press conference that didn't get enough attention. What you're seeing here represents roughly 40% of the light that's actually out there. The rest is too faint, too distant, or too redshifted for even Webb to detect. Let that sink in. This image showing 45,000 galaxies is only capturing 40% of what exists in that patch of sky. The full picture would show over 100,000 galaxies in an area smaller than a grain of sand. Multiply that across the entire sky. The numbers become absurd. The observable universe has a radius of about 46.5 billion light-years in every direction. That's not because the universe is only that large. It's because light from anything further away hasn't had time to reach us since the Big Bang. Inside this observable sphere, based on Hubble's surveys, astronomers estimated about 2 trillion galaxies existed. That number came from extrapolating Hubble deep field observations across the entire sky. But Hubble was only seeing the brightest, largest galaxies. It was missing the faint, distant, small ones. Lots of them. Webb doesn't miss those. Its infrared vision penetrates cosmic dust. Its sensitivity detects objects 100 times fainter than Hubble could see. And when astronomers took Webb's observations and recalculated the total galaxy count, the number exploded. Over 20 trillion galaxies. Maybe as many as 40 trillion, depending on how you account for the faintest, most distant objects. That's not a small revision. That's a complete recalibration of cosmic scale. Let's try to understand what 20 trillion galaxies means. Not just as a number, but as actual scale. Start with our galaxy, the Milky Way. It contains approximately 200 to 400 billion stars. Some estimates go higher. Our Sun is one of them. Just one ordinary star among hundreds of billions. The Milky Way is about 100,000 light-years across. Light traveling at 186,000 miles per second takes 100,000 years to cross from one side to the other. That's how big our galaxy is. Now scale up. The Milky Way is part of the Local Group, a collection of about 80 galaxies spanning roughly 10 million light-years. The largest member is Andromeda, slightly bigger than the Milky Way. The rest are smaller dwarf galaxies orbiting the larger ones. The Local Group is part of the Virgo supercluster, a massive structure containing at least 100 galaxy groups and clusters, spanning about 110 million light-years. But even the Virgo supercluster is small compared to the Laniakea supercluster, a vast cosmic structure containing 100,000 galaxies across 520 million light-years. Our Milky Way sits near the outer edge, and Laniakea is just one supercluster among millions in the observable universe. The universe is organized in a hierarchy of structures, each level vastly larger than the previous one. Stars cluster into galaxies, galaxies into groups, groups into clusters, clusters into superclusters, superclusters into filaments forming the cosmic web. This cosmic web, the largest known structure in the universe, consists of vast filaments of dark matter and galaxies surrounding enormous voids, empty regions where almost nothing exists. The scale is incomprehensible. The Hercules Corona Borealis Great Wall, one of the largest known structures, stretches over 10 billion light-years across. That's about 20% of the observable universe's diameter. It contains billions of galaxies organized into a vague, wall-like structure. And all of this, every structure we can observe, every galaxy cluster, every supercluster, every filament of the cosmic web, exists inside the observable universe's 93 billion light-year diameter sphere. But here's the thing that really melts your brain. The observable universe is probably not the whole universe. It's just the part we can see, the part where light has had enough time to reach us since the Big Bang. The actual universe is likely much larger, possibly infinite. If the universe is infinite, then there are infinite galaxies, infinite stars, infinite planets. Everything that's possible happens infinite times. There are infinite versions of you reading this right now. Infinite Earth-like planets, infinite civilizations. We don't know if the universe is infinite. Current measurements suggest it might be, but we can't prove it. What we do know is that the observable universe, the part we can actually study, contains at least 20 trillion galaxies. Let's do some math. If each galaxy contains an average of 200 billion stars, and there are 20 trillion galaxies, that's 4,000 stars. 4 septillion stars in the observable universe. And current estimates suggest that most stars have at least one planet, so that's potentially 4 septillion planets as well. How many of those are habitable? How many host life? How many have developed intelligence? Even if only 1 in a trillion planets develops intelligent life, that's still 4 trillion civilizations in the observable universe. We should be drowning in alien signals. The universe should be teeming with life, with intelligence, with civilizations far more advanced than ours. Yet we hear nothing, see nothing, detect nothing. The Fermi paradox becomes even more paradoxical when you realize the true scale of what's out there. Webb hasn't just shown us more galaxies. It's shown us galaxies we didn't think existed. Galaxies that challenge our understanding of cosmic evolution. Take the galaxy JWST. It appears as a small red smudge in Webb's deep field, barely distinguishable from background noise. But spectroscopic analysis reveals it's one of the most distant galaxies ever observed, existing just 320 million years after the Big Bang. According to our models, galaxies this early should be small, dim, chaotic. Gravity hasn't had enough time to organize them into structured systems. But JWST is bright, organized, and contains an estimated 1 billion stars. 1 billion stars existing when the universe was 2% of its current age. The timeline doesn't work according to standard stellar formation models, and it's not alone. Webb has found hundreds of these early, massive galaxies, each one pushing the boundaries of what should be possible in the young universe. In Webb's images, you can see galaxies at different distances, different ages. The foreground galaxies are large, bright, clearly defined spirals and ellipticals. These are relatively nearby, existing in the recent cosmic past. Behind them are smaller, redder, more distant galaxies from the middle epoch of cosmic history, 5 to 10 billion years ago. And at the very edge of visibility, faint red smudges, barely distinguishable from noise, are the most distant galaxies, primordial structures from cosmic dawn. And there are thousands of them. Every deep field image Webb produces reveals more. The Good South Field, observed for over 700 hours of total exposure time, shows layer upon layer of galaxies stretching back through cosmic history. You can trace cosmic evolution by depth. Nearby galaxies are mature, organized, filled with old stars. Mid-distance galaxies show active star formation, bright blue regions where new stars are being born. The most distant galaxies are chaotic, irregular, still forming. But what's shocking is the sheer number at every distance. The universe isn't sparse, it's packed with galaxies. Every direction you look, every patch of empty black sky is actually teeming with galaxies if you look deep enough. And here's what keeps astronomers up at night. We're only seeing the bright ones. For every galaxy Webb detects, there are probably 10 or more too faint to observe. Small dwarf galaxies, dim, low-mass systems. Galaxies that formed, lived and died without ever becoming bright enough for our instruments to detect. The true galaxy count could be 100 trillion or more. We literally don't know. We're estimating based on incomplete data, extrapolating from what we can see to what we can't. Now let's talk about what we can't see. Because the observable universe, as vast as it is just a tiny fraction of everything that exists. The particle horizon, the boundary of the observable universe, exists not because the universe ends there, but because light from anything beyond hasn't reached us yet. The universe is 13.8 billion years old. Light travels at a fixed speed, so we can only see objects whose light has had time to travel to us. But the universe has been expanding the entire time. Objects that emitted light 13 billion years ago have since moved much further away due to cosmic expansion. By the time their light reaches us, they're actually over 40 billion light years distant. This creates a horizon. Beyond it, the universe continues. Galaxies exist, stars shine, planets orbit, but their light will never reach us because space is expanding too fast. They're beyond our cosmic horizon, forever invisible. How much of the universe is beyond our horizon? We don't know. If the universe is infinite, then 100% of it is beyond our horizon. The observable universe would be infinitesimally small compared to the whole. Even if the universe is finite, cosmological models suggest it's at least 250 times larger than the observable universe. That means for every galaxy we can see, there are at least 250 we can't. For every star, 250 invisible stars. For every planet, 250 unreachable worlds. And this is a conservative estimate. Some models suggest the universe could be billions or trillions of times larger than the observable portion. Maybe infinitely larger. There's also the question of what happened before the observable horizon was established. In the early universe before cosmic expansion accelerated, information could travel further. The universe was smaller, denser, and more interconnected. Then dark energy kicked in. Expansion accelerated. Distant regions of space moved beyond each other's horizons. Today, galaxies on opposite sides of the observable universe can't see each other. They're beyond each other's particle horizons, separated by space expanding faster than light. This means causality has limits. Events happening in distant galaxies right now will never affect us. Their light will never reach us. If a civilization exists 50 billion light years away and sends a signal, we'll never detect it. The space between us is expanding too fast for information to cross. We're in a causally disconnected bubble. Everything inside the observable universe can theoretically interact. Everything outside is in a separate, inaccessible bubble. And if cosmic expansion continues accelerating, which current evidence suggests it will, the observable universe will, actually shrink over time. Distant galaxies will accelerate beyond our horizon and disappear from view. In trillions of years, future civilizations will look at the sky and see only their own galaxy cluster. Everything else will have expanded beyond visibility. They'll think they're alone in the universe because they'll have no evidence that anything else exists. Let's bring this back to human scale for a moment and really grasp what Webb is showing us. Imagine you're standing in a completely dark room. You light a match. The tiny flame illuminates maybe 10 feet around you. Everything beyond that is darkness, but you know the room continues. That's our situation. The observable universe is the area illuminated by the match. Everything we can study, observe, measure exists within that small bubble of light. But the room, the actual universe, is vastly larger. We just can't see the rest of it. And unlike a dark room, we can never walk forward and illuminate more of it. The darkness is fundamental. It's not dark because there's no light source. It's dark because light from those regions hasn't reached us and never will. Now, Webb has essentially shown us that our match is illuminating far more than we realized. We thought we saw everything within the light. But Webb's sensitivity revealed that the illuminated space contains 10 times more objects than we thought. Tiny details we were missing. Distant features at the edge of visibility. And if the nearby space contains 10 times more than expected, the total room, the full universe, must be proportionally larger too. This recalibration affects everything. Cosmological models, dark matter distribution, the abundance of heavy elements, the probability of life. Every calculation about the universe that relied on the galaxy count needs revision. Every estimate about habitability, intelligent life, or cosmic resources was based on incomplete data. We've been working with a map that was missing 90% of the landmarks. Our understanding of cosmic structure, evolution, and composition is being rebuilt from the ground up. And here's what's humbling. Webb is the most powerful telescope we've ever built, and it's still only scratching the surface. It's showing us more than Hubble, but it's not showing us everything. There are still fainter galaxies it can't detect, still more distant structures beyond its reach. The next generation of telescopes, currently in planning stages, will be even more powerful. They'll see deeper, fainter, further, and they'll undoubtedly reveal even more galaxies we're currently missing. The true scale of the universe is something we're still discovering. Each new instrument reveals that our previous estimates were too small. The universe keeps getting bigger the harder we look. At some point, we have to accept that we'll never see the whole picture. We'll never know the true total. We can only observe our small bubble and extrapolate, knowing that our extrapolations are probably still underestimates. So what does it mean that there are 20 trillion galaxies instead of 2 trillion? What changes when we realize the universe is 10 times larger than we thought? On a practical level, not much. We're still confined to Earth. We haven't even left our solar system as a species. The nearest star is 4 light-years away, effectively unreachable with current technology. Other galaxies are millions or billions of light-years away. Whether there are 2 trillion or 20 trillion galaxies doesn't change our immediate situation. We're still isolated on a small planet orbiting an average star in an ordinary galaxy in an unremarkable region of space. But on a philosophical level, everything changes. If the universe contains 20 trillion galaxies, each with hundreds of billions of stars, each potentially hosting multiple planets, then the probability of life elsewhere becomes near certainty. We cannot be the only ones. Statistically, mathematically, it's almost impossible. Yet we see no evidence, no signals, no megastructures, no signs that any of those trillions of civilizations that should exist have ever visited, colonized, or even acknowledged us. The great silence becomes more deafening the larger the universe gets. If there are 10 times more galaxies, there should be 10 times more intelligent species. Where are they? The Fermi paradox intensifies. Either intelligence is extraordinarily rare, far rarer than we think, Or something prevents civilizations from becoming visible across cosmic distances. Or maybe we're looking at the wrong scale. Maybe intelligence is common, but the universe is so incomprehensibly large that even millions of civilizations are too spread out to ever find each other. Space is not densely packed with stars. Even within galaxies, stars are separated by light years. Between galaxies, the distances become absurd, and between galaxy clusters, there's mostly nothing. Vast voids where space expands and time passes, but very little happens. If civilizations are scattered across 20 trillion galaxies, the average distance between them could be millions or billions of light years. Signals would take millions of years to travel between them. By the time a reply arrives, the original civilization might be extinct. Maybe the universe is filled with life, intelligence, and civilization. Maybe there are billions of species looking at the stars, wondering if they're alone, but the scale is so vast that finding each other is effectively impossible. We're all shouting into the cosmic void, separated by distances too large to cross and times too long to wait. James Webb revealed the true scale of the universe. Not the full scale, we'll never see that, but more of it than we've ever seen before. And what it showed us is that we drastically underestimated how big everything is. 20 trillion galaxies, 4 septillion stars, more planets than we can count. A universe so vast that our entire observable bubble is probably just a tiny fraction of the whole. This is humbling. We're not just small, we're incomprehensibly small. A single planet orbiting a single star, in one galaxy among 20 trillion, in an observable universe that's probably just a tiny speck of the total. And yet here we are, conscious, aware, able to build telescopes that can see across cosmic distances and measure light that's been traveling since the universe was young. We're small, but we're capable of understanding scale. That's extraordinary. The universe is bigger than we thought. And every time we build a better telescope, it gets bigger still. Maybe it's infinite. Maybe there's no edge, no boundary, just endless space filled with endless galaxies stretching forever in all directions. We'll probably never know, but we can keep looking, keep measuring, keep discovering just how much bigger everything is than we imagined. What do you think? Does it comfort you or terrify you that the universe is this unimaginably large? Drop your thoughts below. And if you want more mind-bending realizations about the cosmos we inhabit, subscribe. Because Webb is showing us wonders every day, and the scale of what we're discovering keeps expanding.